Hello students, my name is K. Ramalakshmaya, Department of Physics, Assistant Professor, part-time, Dr. B.R. Ambedkar Open University, Jubilee Hills. So now discuss a topic, a semiconductor device. This semiconductor device is electronic component that is used the properties of semiconductors material to function. So functions, this is two type of main concept are conductors and insulators. So conductors are using the capacitors and resistance, that is depending on that one. Here insulators mean the resist of prevent is the flowing of the electricity and heat or sound. So the concentration electronic holes directly influence of the magnitude of the current. So this is a single crystal semiconductor. This is single crystal semiconductors, that is the holes and electronics is equal to depending on the materials. So that is the materials here using the different type of semiconductors. Our semiconductors is various of the special semiconductor device. For example, basic diodes, transistors, FET to UJT, MOSFET to SCR. This is the different type of the semiconductors there. So there are various of the type of special semiconductors. Special semiconductors means basic diodes. Basic diodes are transistors. So for example, diodes is depending on the type, N type and C type semiconductors. N type mean that is the depending on the type is the material using germanium and silicon. Germanium and silicon is depending on the, this is bandwidth. This is the bandwidth. Okay, look at here, see here. So N type semiconductors, that is the semiconductor light silicon, germanium, gallium, arsenide are key to this device. So here look at here, this C, here silicon is a double band, is single band there. So P mean two dimensional representation of the silicon, that is doped with the phosphorus atom. So this is the phosphorus atom. This is phosphorus atom is depending on the electrons, that is the electrons. So this is N type semiconductor. Okay. So next to P type semiconductor. P type semiconductor is also same band, silicon, you take the material is a silicon. So here boron, first one is N type, here what, phosphorus. So P type mean here it is the phosphorus, N is phosphorus, P type is boron. So here is also same, two bands, two dimensional representation of the silicon lattice doped with the boron atom. Okay. So next to this is, for example, different type of diodes. Different type of diodes mean that is the main concept of the 5 types of diodes. One diode is Zener diode, tunnel diode, photodiode, light emitting diode, radical diode. Okay. So diode mean here, look at here, this one main concept. This is the diode. So for example, this is the anode, this is the cathode. This is what is the diode mean for diode, photodiode, electrical diode plus light emitting diode, tunnel diode. This is the symbols is main concept of the this point. Okay. Diode only is straight line here. This is the diode is only straight line. This is anode, another one is cathode. So tunnel diode mean tunnel diode, this is the pin type symbol. Okay. This is the pin type. Okay. So this is also same anode and cathode. So this is the tunnel diode symbol. Okay. After that, this is the main concept of the Leo Szilard introduced by the 1958. Okay. So main this is introduced mean this is the PN junction. This is the doped by PN junction. So P mean positive, N mean negative. It both are junction is the depending on the diodes. Okay. So this is the main part is the concentration. Main part is the concentration. One part 10 power 3. One part is 10 power 3. This is compared to one part in 10 power plus 8 in the PN junction diode. Plus PN junction diode, that is the tunnel diode. Okay. So here this is the depending on the width. What is the width? This one you find out the depletion layer is very small. Depletion layer is very small, that is 100 amperes. So is the generally made of germanium and silicon. A diode is the mainly made of germanium and silicon. Okay. So these are so tunneling phenomenon. The phenomenon. Next, this is a circuit symbol. This one is the circuit. Okay, tunnel diode circuit diode symbol means this one. No? Okay. So next, this is the tunneling is the depending on the graph. So what is tunneling? This is the graph. The classically carrier must have energy at least equal to potential barrier. This is the potential barrier. You draw the is the graph. So first this is the y-axis. It take the potential energy is the y-axis. The space device is the x-axis. It take that one. It draw the graph. Slowly is triangular wave. So here, okay. So this is triangular wave, that is depending on the least equal to potential barrier height to cross the junction. This height to cross the junction. Okay. So this is the phenomenon is called the tunneling, and the elastic diode as the tunneling diode. Okay. So this is only tunneling diode. A tunneling diode is also equivalent to circuit, that is also depending on the resistance and capacitors and inductors. Okay. So here it coupling the resistance and capacitor and inductors, that is equivalent to the circuit bias in the negative resistance region. This is the negative resistance region, capacitor and this resistance. Here also this symbol is inductor, this symbol is resistance, this is the capacitor. Okay. Okay. You see this one, the higher frequency the series R and L. R mean resistance, L mean inductor. Okay. This is the this one R mean this is the resistance, another one is L mean resistance inductor. Okay. So next they reduced by the parallel combination of the junction capacitance and negative resistance. So this is the only tunnel diode. After that, second one is Zener diode. Zener diode is mostly you find you calculate that one breakdown voltage. Okay. This is Zener diode as a voltage regulator. A voltage regulator is two types, that is line regulation and load regulation. Here you are using this one only line regulation and load regulation, that is depending on the Zener diode. Okay. So you are observe almost the tunnel diode and Zener diode symbol is also you look at here. So this is Z symbol. Okay. Tunnel diode which symbol? This is pin symbol. Tunnel diode is a pin symbol. Zener diode is Z symbol. This is the Z symbol. Okay. So here IZ mean Zener current, VZ mean Zener voltage. Okay. This is also same positive and negative cycle. This one. Zener diode as a operate the always reverse bias. This is the always reverse bias. It calculates the breakdown voltage. If breakdown voltage is also it calculates is the common Zener voltage value. So this one common Zener voltage value minimum 1.8 volts, maximum 200 volts. Okay. Minimum to 1.8 volts to maximum to 200 volts. That value depending on the Zener region. For example, you see this one is the graph. Okay. Why are telling this one? Zener diode always reverse bias mean. So this is the forward bias. This part is forward bias. This part is reverse bias. Okay. So forward bias current is slowly is increasing part, this one here. Okay. Origin point this one slowly is increasing part. Here negative reverse bias mean this line. So slowly is constant is came, after the suddenly is a decreasing. This point breakdown voltage. So you reach this one. This is the diode is in the reverse bias condition. The some point the reverse bias voltage is the large the diode breakdown. Okay. So at the same time this is the breakdown. Where is the point is a breakdown? This point is a breakdown. This is maximum voltage. This is the maximum voltage, or maximum voltage is going to break down. That value is avalanche breakdown voltage. Understood? This point is avalanche breakdown voltage. That point, avalanche point, mean maximum point. Don't use the minimum point and middle point. This is the maximum point is avalanche breakdown voltage. Okay. So, and the voltage and current, avalanche current. Okay. So, here the resistance levels. Resistance levels is, this is the depending on the AC current and DC current. So, this is the semiconductor as differently to DC and AC current. Okay. So, there are three type of resistance. There are three type of resistance, that is the DC or static resistance, AC and dynamic resistance. Another one is average AC resistance. Okay. So, after that, the resistance of the diode at the particular operating point is called the DC or static resistance diode. Okay. So, it can be, this is the formula, you will determine the equation RD is equal to VD by ID. So, here which one is the RD and VD? This one ID. Okay. This is the ID mean drain current, this one VD is drain voltage, that is equal to IRD, drain resistance, small r mean drain resistance, RD is equal to VD by ID. So, drain resistance is equal to drain voltage by drain current. Okay. So, here AC or dynamic resistance formula or circuit. So, AC or dynamic resistance, that one, a static resistance is using DC input. Okay. Further, in the input is a sinusoidal, in the stanio will be changed. That is, you see this the graph AC resistance can be determined by the picking 2 points. You are looking here 2 points mean, draw the values, graph, delta ID value is the y axis, delta VD value is the x axis, you take the both values. After that, draw the graph, slowly is some value is the constant, after slowly is this one is increasing. Okay. Further, which value you find out this one, here state point, this one you look at this point, and under same point is down face this one, this point, ఈ 2 points, between 2 points on the characteristics curve developed for the particular point. Okay, ఈ 2 points there. Okay. So, this is the wherein the input move the instantaneous of the operator point up and down of the region. This is the up mean, this is the up region, and this one is down region. Okay. So, formula already I am telling this one formula, RD is equal to delta VD by delta ID. This is also same is the formula. So, this is only diodes. For I am taking the only 2 diodes. Which one is the tunnel diode and the Zener diode, that is the most important 2 diodes. After that, second one special semiconductor transistor. So, what is the transistor? What is the transistor mean? Transistor 3-terminal silicon semiconductor device. 3-terminal silicon semiconductor device mean base emitter collector. Base emitter collector, that is the transistor. Okay. So, a transistor, the construction, this is the 3 layers semiconductor device. 3 layers mean base emitter collector. Okay. So, that is also transistor is 2 types, NPN transistor, another one is PNP transistor. So, here you look at here 2 transistors, NPN transistor and PNP transistor. NPN mean 2N 1P type layer. Okay. 2N 1P type layer, that is NPN transistor. At the same time you look at this is a PNP transistor. Here is also same 2P 1N type layer material. Okay. So, this is NPN and PNP transistor. So, this is also depending on the transistor, you are using BJT, FET2, MOSFET2, JFET2 and SCR, that is using this transistor. So, here first you discuss the BJT. BJT means the terms of the bipolar reflex. BJT mean bipolar, T mean transistor, BJT. bipolar junction transistor, that is a BJT. Okay. So, reflects the fat of the hole and the electrons participate in the injection of the process into the oppositely this is the polarized material. Okay. So, this is also a transistor is a PN junction as a two different type of bias. Two different type of bias means these are bias both PN junction and NP junction, and transistors also using the NPN transistor and PNP transistor is also using this one. Both sides is almost is equal. These are two types mean forward bias and reverse bias. Okay. So, if forward bias and reverse bias already I am telling this one this graph. So, this point Gina died for example region. So, this is the forward bias concept. Okay. So, here too slowly is the increasing part, another one is this part is reverse bias and forward bias. So, this is a two PN junction device. So, position of the terminals and symbol of BJT. Already I am telling the BJT mean bipolar junction transistor, that is the base is located at the middle and more thin from the level of collector and emitter. So, here collector and emitter you see this diagram. So, this diagram mean, so look at this is the PN junction, here is also PN junction. So, you are observe this one, the PN junction base, emitter and collector. Here is also here PNP, okay, here NPN. So, here base, collector and emitter. So, this is the block diagram. So, further you are using the transistor. So, I am telling you already three terminal mean here base, emitter, collector. Okay. Here PMP symbol and NPN symbol, what is the different mean here? This is the arrow mark symbol is this side. Okay. Here is NPN transistor symbol mean this side. Okay. This is the various is the part. So, here BJT value B mean this or this. Okay. Emitter, collector mean this, emitter, collector. Okay. PNP and NPN. That is a both different mean the arrow mark symbol is a variation that. You always you take the arrow mark symbol emitter phase, emitter position. Okay. So, look at this. So, thin from the level of collector and emitter. Okay. The emitter and collector terminals are made of the same type of semiconductor material. Both emitter and collector is the same made of the semiconductor material, only base is the other type. Okay. Other type of the material. Okay. So, next to transistor current. So, transistor current is also almost three terminals. This is also same PNP and NPN transistors. Here base, emitter and collector is also same here observe. This is a base, IB mean base current, IG mean emitter current, IC mean current collector current. Okay. This is the emitter, same symbol is also located same NPN. Another one is also PNP transistor. This is also IB mean base current, emitter current. This is also collector current. So, there is the always draw the emitter, the arrow always point off towards the N type. Okay. The arrow indicates the direction of the emitter current. PNP, E symbol, you look at this one, E arrow mark symbol this one, EP is B, okay, NP is B to E. Here once again here PNP E to B, okay, E to B. So, here E to B, NPN mean B to E. So, here NPN B to E, okay na. So, already I am telling this one, IC mean IB value, IG value also, the collector current value IC, as base current IB value, as emitter current. The transistor operation. The transistor operation will be described the using the PNP transistor. This operation if the PNP transistor is exactly the same if the roles played by the electron and hole are interchanged. That is the next the one PN junction of the transistor reverse bias, whereas the other part of the forward bias. Okay. So, this is the transistor, two types is two types is the transistor, this one. The what is the forward bias and reverse bias is the depending on the this circuit way. So, what is the forward bias and reverse bias mean? You are looking at this one. So, this is the base, this is the emitter, another one is collector. So, this is circuit you are observe, this is the battery, plus and minus is a, this is the key. After that VEE, the forward bias junction of a PNP transistor. PNP transistor also your plus and minus, your plus of minus. This is the majority carries. This is the majority. Which one is the majority carriers? PNP transistor is the majority carriers. Another one is at the same time PNP transistor. This is also PNP transistor. Which one is the different? This is forward. This one is reverse. Forward bias junction and reverse bias junction. This is the only different is this is the majority carriers. This is the minority carries. Okay, no? So this is also base, emitter, collector. The depletion region mean this part only. This part is the base part, at P part. This part is P part. Middle part is N. Okay. So this is the depletion region. At the same time, region also same. This part is the depletion region. This part is only this color. N part. This is the P part. This is also P part. Okay, P type. Okay. So this is the forward bias junction and PNP transistor, and reverse bias is the junction of the PNP transistor. Both circuits is including this circuit. Okay. So this one you look at here. This also this part and this part totally is the depletion layer regions. Okay. Here majority carriers and minority carriers mean already I am telling this. This part is this part to here totally is P type. Another one is P type. This middle part is N type. Here emitter current and emitter current and collector current. This is the base current. Okay. You see this one VGG and VCC is the dependent the both. This is the NPN reverse bias, forward bias circuit. This is the reverse bias circuit. This one VGG is the forward bias and VCC is reverse bias. This one, this both is this. What? So both bias in the potential have the been applied to the PN junction transistor, and result is the majority and minority carriers flow the indicate this one, the circuit this one. So further, same this is the own transistor, the concept of the formulas. That comprises of the two component of the majority and minority carriers. That formulas is IC is equal to IC majority plus IC minority formulas. That is equal to here ICO minus IC it current with the emitter terminal open and is called the leakage current. That is the this formula is leakage current. Further, this is the important field effect transistor. Field effect transistor, this is using also 3 terminal silicon semiconductor device. Okay, na? So this is also sadly had to idea of the making the solid state device of the semiconductors. The field effect transistor, this one. Next to this the briefly is also explanation of the workings of the transistor and germanium point of the contact the transistor. Further, main concept is also this field effect transistor circuit. The family of the FET may be divided into the different types. This FET is the depletion mode MOSFET, enhancement mode MOSFET, JFET consists of the piece of the high resistivity as semiconductor material. This is the JFET. BJT is the low resistivity of the semiconductor. This is also FET. Okay. So this is also same. You are looking at this one. This is also transistor. This is also transistor. So here transistor is also names is changed. Transistor base emitter collector is that one. Here it is in the field effect transistor mean you change the base mean gate, collector mean source, emitter mean source, collector mean drain. Okay. So here names is changed gate, drain, source. Okay, here is also source, gate and drain. So this is the N channel and P channel is the both side there. This is the basic structure, this one. This also P type and N type, this one, the depletion region, this one also, here is also same. So both is also metal is a P type value. Here is also look at the, this is the transistor gate and drain and source. So here VGS, VDS, ID both three values is changes, this one VDS, VGS, ID. ID mean drain current. ID mean drain current. VGS mean gate source voltage. Gate source voltage. VDS mean drain current voltage. That is the concept. So here you gate, drain, gate, source. This is the channels is this one flow in the negative channel. Okay, total is here to you see this here to negative channels. So this is also always reverse bias. FET is also always reverse bias. You calculate this is the voltage. Okay, so next to this is the basic structure. Also I am telling this one JFET and MOSFET is also same, this one. Next to how to JFET is the function is also same. Here circuit, this one NPN transistor, this one is also okay, gate, source, drain. This is also channels of depletion of the layer, different type of the layers. The gate is connected to the source in the PN junction reverse bias, and little current will be the gate connection. Okay. So next to UJT. UJT is also very important. UJT mean uni junction transistor. Uni junction mean only single junction, single connection. This is also depending on the NPN transistor. PET mean depending on the PNP transistor. That is, you calculate the voltage. That is always is a reverse bias. UJT is uni junction transistor. This is using the using the transistor NPN transistor. This is always forward bias. You calculate the current. Okay, na? You calculate the using the current. Okay, current. You see this one. This is also same 3-terminal silicon semiconductor. 3 terminals mean this is you see this one here. This is 3 terminals mean a base, emitter and collector. Okay, this one. Okay, here also. Here UJT is the names is changed. FET is base on gate source voltage, gate source drain. Here UJT is gate, this one. Here UJT mean emitter, base 1 and base 2. Names is changed. Okay, same connection is resistance is capacitor is same. That is PNP and this is the NPN, but names is changed, that one. So here base 1 and base 2 and emitter. Okay. So this is the 3 terminals mean this one 3 pins there. The one is emitter, another one is collector and base. Okay. So unipolar junction transistor, this one. So look at this one PN junction, this one. So channel is formed by the N type, which the lightly doped with the P type material has increased the doped concentration of the P type very high. Okay. FET is very low. Opposite FET and UJT is the opposite and okay. So this is the uniform single PN junction, and this is the reason of the name uni junction. The terminals base 2 B2, base 1 and emitter, that one. This complementary type of UJT made the P type lightly the doped channel with the heavy doped. That is heavy doped mean N material, N type of materials. Okay, na? N type of materials, that is B1 and B2. Okay, na? P type of material, that is only emitter. Okay, the N type of the material. So you see this one graph. You take the VD value is the x-axis, ID value is the y-axis. You take this point, is draw the graph. Further, this point here, you see this one here main point. This point is the cutoff regions. This point is cutoff regions. What is the cutoff regions mean? Here negative points is completed is remove that. Further, you origin point to continue to you move the positive point, positive cycle. So that is the point. Where is the point is the cutoff region mean this point here. This is the concept. Okay, na? So this is the cutoff regions. So this is the characteristics of the unijunction transistor, is cutoff regions point. This is the on and the applied the voltage did not reach the triggering voltage. Okay. So in negative resistance region is also same approximately. The further the voltage reach the triggering voltage, the device is turned on of the emitter voltage reach the peak voltage and the drops of the value of point. Okay. Next, silicon controlled rectifier. Silicon controlled rectifier. This is also important. This is also depending on the transistor. This is 3 terminal anodes. 3 terminals mean same emitter, base and collector. Okay, na? This is also PNP transistor. This is the anode and cathode. Okay, the cathode. This is also N layer is the opposite end and gate is a P layer is a cathode region, means this point. This is a anode, means this sum. This is the anode region and another one is cathode region, this point. It connected power such that the anode is positive. So this is a positive. Okay, the cathode mean negative. So this point negative. Okay, this is the 2 junction, means blotted by the reverse bias the 2 junction. This is the blotted by the 2 junction. Here is the silicon circuits is a different diodes. Here gate, anode and positive. So this is the this is the graph. Slowly is the some points is the increase in the positive cycle, mean anode raise this one. This is the negative cycle to this is the move the SCR. Okay, this is the turned and the one term is the gate. So silicon controlled rectifier. This silicon rectifier control is also dependent on the FET UJT, that is the dependent same method. But this is also same, name is changed. Which one is the name change? This one here gate, anode and cathode. Okay, no? So this is the SCR silicon controller the rectifiers. Okay, thank you.